So what exactly is an electron? Well, an electron is a subatomic particle with a negative charge found in all atoms. The electron orbits around the nucleus of an atom, where protons and neutrons reside. They stay in orbit because of their attraction to the nucleus, which is an oppositely charged entity. Each electron resides in its own orbital of an electron cloud. They are constantly moving around the nucleus but never get too close. It may seem like all the electrons do is have fun and frolic around all day, but their role is a very crucial one. These itty-bitty particles actually fuel huge chemical reactions, make electricity, and make your colors vibrant as you like it. Now, how do they do this? Energy levels. You see, as an electron gains energy from something like a photon, it jumps into an excited state. It's like a 4-year-old that just ate a whole bucket of pure sugar. It goes up an energy level and is now on a whole another cloud of crazy. Every electron wants to be in its ground state. That's its most stable state. And it is for the most part, until extra energy is transferred to it, usually by waves. This can be light waves, microwaves, all that fun stuff. And once the energy is transferred, it is now in what we call an excited state. It jumps up a level. Now, one crucial component of this whole energy interaction is that the electron can only give off the same amount of energy it received. This amount of energy is referred to as a quanta, meaning quantized or measured. Electrons cannot emit the energy part way. It must give or gain enough energy to jump an energy level, like popcorn. Like the electron, the popcorn pops into another state once enough energy is transferred to it. Granted, the electron does not turn into salty, buttery goodness, but the concept is the same. Another thing to notice is that the kernel of popcorn either jumps or it does not jump. There is no walk. This also reflects a property of the electron. It either jumps or it doesn't. As we mentioned in our class, it is very much like a bus ticket. You either pay the $1 fare to get on the bus or you don't get on the bus at all. The electron basically does the same thing, except instead of paying a $1 fare, it pays a 1 quanta fare to jump an energy level. Now, as I stated earlier, every electron wishes to stay in its ground state. When the electron is in excited state and wants to jump down back to the ground level. How does it do this? It does this by releasing the energy it gained, by releasing the energy that it gained. One of the ways it releases this is via a photon. It basically just spits back out the photon. This release of energy and its wave is individual to the atom. A hydrogen atom releases a unique color spectrum compared to the other elements, like mercury. The colors you see here reflect the interaction of photons and electrons for the hydrogen atom. Now, let's say that this little electron gets so excited it just completely jumps away from the atom and can never fall back down to ground state. What happens then? Well, plasma happens. The atom becomes ionized. Now, what is ionization? Ionization is one of the principal ways that radiation, such as charged particles and X-rays, transfers its energy to matter. An ionized atom is basically a hot mess of atomic soupy stuff. Plasma is a cloud of protons, neutrons, and the electrons, where all the electrons have come loose from their respective atoms. Whenever someone says plasma, people think that it's some exotic, like, rare thing. No, you can actually make it in your microwave with a grape.
In order to make plasma in your microwave, you only need a few things. You need a clear glass, 2 Tupperware lids to prop the glass up, grapes, and a microwave you don't mind completely obliterating. The most important part to this experiment is how you cut the grape. First, you're going to want to cut the grape in half, and then with that half, cut it straight down the middle, but you leave the skin at the very bottom intact. So in the end, it should look a little bit like this. And then after you've cut it correctly, you're going to want to put it down on a piece of paper. Make sure it's face down, and then you will leave it there to dry for about 5 to 10 minutes. After the grape has dried enough, you're going to want to put it in the microwave like so, with the glass covering it, that way the plasma doesn't get all over your microwave. And then you're going to want to put it in there for 15 seconds.
How in the world does this actually happen? Well, basically, the electrons were ripped from their orbits because the microwaves gave them enough energy to do so. How? Well, your microwave warms your food by blasting microwave radiation through your foodstuff, which disturbs the water molecules, causing them to vibrate. This friction creates the heat that makes your dish warm. In our case, however, the microwaved item is small and can only take a small amount of microwave radiation. The size of the grape causes the radiation to become very concentrated on its tissue, so much so that the radiation rips some of the molecules apart, generating charged ions. Eventually, the small electromagnetic field forms, causing the ions to flow from one half of the fruit to the other via the skin that we had left intact earlier. This process destroys the connective tissue, and at this point the ions leap through the air. This produces the plasma we see in the video. But basically all you really need to know is that electrons leave their orbits because they were given enough energy, and now you have plasma in your microwave and a completely destroyed microwave. Alright, so that's all for our video. I hope you enjoyed it and come away from this with a different view on grapes and microwaves. Thank you.